Chapter 7. Matrix Inverses and Transposes. Some of you may have seen this formula. It expresses a multiple linear regression model using matrices. But without knowledge of linear algebra, we cannot see why this model can be expressed using matrices. Knowledge of transpose matrix and inverse matrix enables us to understand what this expression means. Section 1. Transpose matrix. In this section, you will learn what is transpose matrix, properties of transpose matrix. The transpose matrix, also called transposer matrix, is a matrix in which the original matrix is flipped over its diagonal. In other words, we can create a transpose matrix by swapping the rows and columns of the matrix. This operation is denoted by a superscript T. The transpose of matrix A is written as A superscript T, or sometimes A prime. Let's express elements with the matrix as Aij, where I represent a row number and j represent a column number. Here, we have a matrix A with elements Aij. The transpose of A is defined as a new matrix whose rows are the columns of the original matrix A and vice versa. So, elements of the transpose of A can be expressed in this way. The element at position ij in matrix A is the element at position ji in the transpose of A. If matrix A is an m by n matrix, the transpose AT will be an m by m matrix. Let's see a simple example. Let's consider a 2 by 3 matrix A. To find the transpose of A, we swap the rows and columns. The first row of A becomes the first column of the transpose of A. The second row of A becomes the second column of the transpose of A. So, this is the transpose of A. Here, the transpose of A is a 3 by 2 matrix because the original matrix A was 2 by 3. The transpose matrix and its operation have several important properties that are useful in various mathematical and computational applications. In the following, let's explore these properties one by one. First, let's explore the property called double transpose. It is also called involution property. This property says the transpose of the transpose matrix is the original matrix. That is, taking the transpose twice returns the matrix to its original form. Let's take an example. Here's an example matrix A. This matrix is the transpose of A. The first row of A becomes the first column of the transpose of A. The second row of A becomes the second column of the transpose of A. Next is the transpose of the transpose of A. The first row of the transpose of A becomes the first column of the resulting matrix. The second row of the transpose of A becomes the second column of the resulting matrix. We can say that the resulting matrix equals the original matrix A. Let's go on to the next property. The transpose of the sum of the two matrices is equal to the sum of their transposes. This property holds for any matrices A and B of the same dimensions. As an example, let's consider these matrices A and B. The transpose of A plus B is this matrix. And the transpose of A plus the transpose of B is this matrix. As we can see, the transpose of the sum of the two matrices is equal to the sum of their transposes. Let's go on to the next property. The transpose of the product of two matrices is equal to the product of their transposes in reverse order. For any matrices A and B, where the product AB is defined in this way. Let's consider these matrices A and B. The product of A and B can be computed in this way. So, the transpose of AB is this matrix. Next, compute the product of B's transpose and A's transpose. So, the product of B's transpose and A's transpose is this matrix. As we can see, the transpose of the product of two matrices is equal to the product of their transposes in reverse order. Let's go on to the next property. For any scalar C and matrix A, the transpose of a scalar multiple of a matrix is the scalar multiple of the transpose of that matrix. As an example, let's take this scalar C, which equals 3, and this matrix A. Let's compute the transpose of the scalar multiple. Next, let's compute the scalar multiple of the transpose matrix. As we can see, the transpose of a scalar multiple of matrix A is a scalar multiple of the transpose of A. Let's go on to the concept of symmetric matrices. A matrix is called a symmetric matrix if it is equal to its transpose. Example of a symmetric matrix is this matrix A. As we can see, the transpose of A equals the original matrix A. Thank you for watching. Please thumbs up and subscribe to my channel.